Hello, I am Mr. Murphy, and in this video we're going to be looking at power standard number 13. Power standard number 13 asks us to basically sketch a graph of a parabola, and we're going to be using simply just the vertex, so it's slightly different than power standard number 12. We're not going to have to find a ton of little pieces. We're just going to find the vertex, and then we're going to use the fact of whether or not the graph opens up or down to help us in graphing. And we will find a couple of other points, but it'll be relatively easy to use those and find those. But first, let's look at a couple of things. Let's recall that an equation in vertex form is in the form y minus k equals a times x minus h being squared. But we really haven't touched on that value for a, and what is that value for a, and what impact does that value for a have on a parabola? Well, if a is greater than 0, then what that means is the parabola is going to be opening upward. If a is less than 0, then the parabola is going to be opening downward. So you can see that that value for a tells us a lot about our graph, so what seems like an insignificant number really is a big clue as far as whether the parabola is going to be opening up or whether the parabola is going to be opening down. Let's look at this example. We're going to sketch this parabola with the equation y minus 2 equals negative 1/2 times x plus 4 squared. Well, just like in power standard number 12, we're going to start by finding the vertex. Remember, the vertex here is going to be a coordinate, and its coordinate h and k. To find the h value or the x value of our vertex, we look at our x in our equation, take the opposite of what's happening to it. So here we have a plus 4, so the opposite of that is a negative 4. So that means my x value of my vertex is going to be a negative 4. Look at the y value, or the y part of the equation, to figure out what the y value of your vertex will be. So it's minus 2 here, so we take the opposite of that is going to be a positive 2. So your vertex is a coordinate negative 4, positive 2. Now remember from the power standard number 12 that we have a line of symmetry here. The line of symmetry is going to be the equation, in this case, x equals negative 4, meaning we're going to have an invisible line here that's going to be going through that vertex. So that means whatever's on one side of the line, the same thing's going to be on the other side of the line. And you can see here that the fact that this is a negative 1/2 means that our parabola is going to be opening downward. So it's going to look something like this when we're done. But we want to be more accurate than just throwing down a general parabola opening downward. So to be more accurate, what we're going to do is we're going to set up an XY table. Now the thing is I don't need to have a ton of points here. If you recall from power standard number 12, to draw a graph, we want to have about 5 points. But the idea here is we're going to have this line of symmetry, and some points that are on one side of the line are going to be reflected, so they're on the other side of the line. So I don't need to actually set up an XY table for 5 points. I just need to come up with 2 more so I can reflect them over that line of symmetry. Now I want to pick 2 points that are close to this line of symmetry, because otherwise if I picked some that are too far out, it's not going to fit on my graph. So I'm going to use negative 3 and negative 2. So to start out with negative 3, I'm going to put negative 3 in our equation here. And to make it a little easier, I'm going to take this minus 2 and I'm going to add it to the other side. So that way we have all of our operations on one side of the equal sign. So to find out what y equals, I'm going to take negative 1/2 times my value for x, which right now we're using negative 3, plus 4 being squared, and then at the end we're going to add 2. So at this point we're going to follow the order of operations. Remember, order of operations tells us to simplify in parentheses first. Negative 3 plus 4 is 1. Square the 1. Well, 1 squared is just 1. When I take negative 1/2 of 1 times 1, well, that's negative 1/2. And negative 1/2 plus 2 is a positive 1.5. So I can graph now the point negative 3 and a positive 1.5 would be right about there. Now I put negative 2 in that equation. So I put negative 2 in here. Negative 2 plus 4 is 2. Square that 2 and you get 4. Negative 1/2 times 4 is a negative 2. And negative 2 plus 2 is 0. So now I can graph that. Negative 2, 0. Now is where that line of symmetry comes in handy. I'm going to reflect both these points I just graphed to be on the other side of that line of symmetry. So this first one that we graphed at -3 and a positive 1.5, well, that was 1 unit to the right of that line of symmetry, so I'm going to have one unit to the left of that line of symmetry. This point here that I graphed at -2, 0, that was 2 units to the right of the line of symmetry, so I'm going to put one that's 2 units to the left of that line of symmetry. And now I have enough points to draw an accurate parabola. So my parabola would look something like that. Okay, I want you to look at this equation for a parabola in vertex form. I want you to look at it and first answer the question, does the graph open up or down? And then I want you to sketch a parabola using the vertex and a couple of other points. When you're finished, just like the previous graph, you should have a total of 5 points that you're graphing, one of which is the vertex. So why don't you take a minute here, pause the video, and hit play when you're ready to check your answer. Okay, here's what you should have done. First off, you can see the fact that this is a negative in front of here means that our parabola, just like the last one, is going to open downwards. So we also have our vertex. Our vertex for this is going to be the coordinate, should have been -5 and a +4. So let's graph that. -5, +4 would be right here. Again, our graph is going to be opening downwards. So what we're going to do is we're going to pick, well, first off, our line of symmetry would have been this line here. So we're going to pick a couple of points near that line of symmetry, like possibly -4 and -3. And maybe to make this easier, maybe you added 4 to both sides, which is always a good idea. So in that way we have the y by itself. So all of our operations are on one side of the equal sign. So I'm going to put -4 in here for x. So it'll be -4 plus 5 being squared, and then plus 4. So -4 plus 5 is 1. Square that, you get still 1. This negative outside of here makes that 1 a -1. Plus 4 gives me 3. So I have the point -4, +3. Put -3 in there for x. When you do that, -3 plus 5 is 2. 2 squared gives us a +4, but this negative outside the parentheses makes that a -4. -4 plus 4 gives me 0. So now I can reflect these 2 points over that line of symmetry. And your parabola, your finished product looks something like that. Well, there you have it. That's power standard number 13. Relatively simple, especially once you know how to find the vertex. It's a pretty easy process. So hopefully you have a better understanding now of what we're looking for with power standard number 13, and good luck on those future power standards.